load on beam. So here we have a figure 2. Figure 2 shows a layout floor plan of a monolithic beam and slab construction. What is meant by monolithic beam and slab construction? It means beam and slab are built together as one body. Okay. So here we have 4-panel slab. Okay, we have A1, 1, 2, A1B, 1, 2, B1, 1, 2, and B1C, 1, 2. So here we have 4-panel slab. So the dimension for each panel are given as follows. Okay, referring to figure 2, question number 1, let's us do together. Refer to your own question. Okay, guys. So referring to figure 2, identify primary beam and secondary beam on the floor and state the beam reference. So here you have to state which one beam is primary and secondary beam, and how to identify it by stating the beam reference. Okay, what is meant by primary beam? As we know, primary beam is a beam which is supported by column at both ends. Okay, so here primary beam, at both ends of the beam we have column. So let's list out the primary beam, guys. So primary beam. So primary beam, here we have, state the beam reference. Beam, okay, A, so 1, 2. Okay, A, so 1, 2. We have column at both ends of the beam. Again, yes, A, beam, B, row 1, 2. Okay, guys, list your own. Next, we have beam, C, so 1, 2. Beam, A, B, so 1. B, C, so 1. A, B, so 2. And B, C, so 2. Okay, so we have 7 primary beams. Okay, guys, hope you understand which one is primary beam. Beam which is supported by column. Okay, next is secondary beam. So what is meant by secondary beam? Secondary beam is a beam which supported by another beam. Beam which is supported by another beam. So as we can see here, secondary beam is beam. Which one? Right. Yes, of course. Beam A1, 1, 2, and beam B1, 1, 2. So state the beam reference there, don't forget. So secondary beam, we have beam A1, so 1, 2, and beam B1, so 1, 2. Okay. So next, okay, a new exposure to you. Here we have 125 millimeter thick brick wall with a high is constructed along beam B1, so 1, 2, 3, with a clear height of the wall is 2.8 meters. Calculate the weight of the wall on beam in kilometer per meter. Assume a wall brick density is 18 kilometer per meter cube. Okay, now means here on beam B12, okay guys, on this beam, actually we have a brick wall. Okay, we have a brick wall on this beam B1 through 12. Okay, the brick wall is 125 millimeter and height of the wall is 2.8 and brick wall density is 18 kilonewton per meter cube. So what is the weight of the wall? So weight of the wall, weight, what is meant by the weight of the wall here? It means we have to find out the self weight of the brick wall lah. So we're gonna find out the self weight of brick wall in kilometer per meter. So how to find out the self weight of the brick wall? It's equal to 125 millimeter. So convert to meter first because we want the final result in meter, right? So 125 millimeter is 0.125 feet times with the height of brick wall 2.8 and times with the brick wall density at 10 kilometer per meter cube. Okay. So from this, yes, we will get 6.3 kilonewton per meter. Okay, easy peasy, right? Because of what? Here you have meter, right? Here you have meter. Here you have kilometer per meter cube. So we already cancel it. So we get kilometer per meter. It's simple like that. Okay, for self weight of brick wall, please consider the thick, high, and the wall brick density. Okay, clear guys? Okay, proceed Okay, next, for question number 3. A beam measuring 350 millimeter deep and 200 millimeter wide support a floor slab with a thickness of 150 millimeter. Considering the width of beam in kilonewton per meter, calculate the self weight of the beam. Concrete density is 25 kilonewton per meter cube. So always remember concrete density 25 is referred to reinforced concrete. Okay, reinforced concrete structure. So calculate self weight of the beam. Okay, so as we know before, how to find out the self weight? Okay, how to find out the self weight is mean okay, say this one is a beam. So here we have the width, here we have the depth. Okay, so self weight same as self weight of brick wall. So please remember guys, self weight of structure equal to area of cross section. Okay, area of cross section times width density. Okay, so area of cross section here is width times depth. Width times depth. Okay, so self weight of beam. Okay, self weight of beam equal to. Okay, so self weight of beam equal to area of cross section. Width given is 0.2. Okay, remember put the width first because we always measure the dimension or take the measurement of any structure, any construction is length, width, depth. Okay, length, width, depth. So here we have width and depth. So write down the width dimension first. So width is 0.2 times depth is 0.35. Okay, remember the unit is in meter. Okay, point. Okay, this one is area of cross section times concrete density. Here is 25. So from this, we get, yes, we will get 1.75 millimeter per meter, guys. Okay, clear? As we sketch the brick wall, let's say our brick wall is like this. So as we know just now, we have the thickness of. So this is the area of cross section. This one is the area of cross section, width times depth. Okay. Also area of cross section times density to find out the separate. Okay, please remember it. Okay, guys. Next is sketch the 3 by 3 area for the. Okay, sketch the 3 by 3 area. So before sketching, what are we going to do is identify either the slab distribute the load to the beam as one-way slab or two-way slab. Okay, so before that I sketch the diagram first. Okay, just consider the part of beam B, B1 and C. Okay, it's beam like this. Okay, panel B1C is wider than B1. Actually, okay. Okay, let's do together, guys. Okay, this one we have B, B1, C, 1 and 2. Okay, so sketch the 3 by 3 area for the slab loading. Means how these two panel slab distribute their weight, okay, distribute their load to this beam B112. Okay, how before sketch, again before sketch we have to identify either the slab panel is one way or two-way slab. Okay, let's check the panel B, B1 slope 1, 2 first. So for panel B, B1 slope 1, 2, Ly over Lx. Okay, refer to your question. The Ly is 7625. 7625. Lx is 3050. Okay, so from here we get 2.5. Okay, which is 2.5 is more than 2. So 1 is more than 2. Okay, remember, once Ly over Lx is more than 2, that is one way spanning slab. It is one way spanning slab. Okay, next we have panel B1, C, so 1, 2. Again, take the Ly and Lx. So Ly for Panel B1 C12 seal as panel B4 7625 is different to the LX. LX is 3660, right? Okay, 3660. So once you divide these two numbers, you will get 2.08. Okay, 2.08 is more than 2. So panel B1C12 also one way spanning slack test. Okay. Okay, once we know how the slack panel distribute their load to this beam, then we can sketch the tributary areas lah. Okay, how to sketch the tributary areas? First, here the LX, right? Okay, so here part of LX. Okay, I write down the dimension first. Okay, so how to sketch the tributary area? So this one is LX. Okay, LX is the shorter span. Okay, shorter span. LY is the longer span. So we divide the shorter span into two parts. Okay, how to divide? You just make the hidden line. Okay, dot, dot, dot. Okay, draw the arrow to show the loop part. Okay, to show the loop parts of slab to beam. Here, it means the longer span of beam will support the load from this slab, and the shorter one will not support any load from slab. Okay, guys? Hope you understand. Okay. Same as panel, same to panel B1C12. This one is LX. So we divide LX into two parts. Okay. Then draw the arrow to show the load part of the slab, the load part of slab to beam. Okay, this is how to sketch the tributary areas at kawasan agihan lantai kepada beban. Okay, sketch the tributary areas for the slab. Kawasan agihan lantai kepada beam means this beam B1/12 will support half of load from slab B1/12 and support half of load from slab B1C/12. Okay, clear guys? Okay. Next, calculate the self weight. Okay, and this F here. Okay, so calculate the self weight of the slab with 150 millimeter thickness in kilometer per meter square. Concrete density is 25 kilometer per meter cube. Again, self weight. Okay, special for slab, the unit for self weight is in kilometer per meter square. Here, per meter square. Because of what? Slab is wide area. Okay, slab is wide area. So we measure the width of slab in meter square, in area, per area, because lantai tu luas, dia besar. Okay, so we always measure, calculate self weight of slab in kilometer per meter square. So it's very easy. We just consider the thickness of the slab. Okay, so here self weight slab is equal to, you just consider the thickness of the slab in meter, 0.15 meter times with the concrete density. Okay, very easy guys. So we get, here we get 3.75 kilonewton per meter square. Why? Please remember, self weight of slab in meter cube. Okay, in meter cube, meter square. Cause of what? Slab is wide area. Beam is because of what? Slab. The width is more than the thickness. Compared to the beam, the width is less than the height or thickness of depth. Okay. Okay, you will remember by yourself after this. Don't worry. Okay. Next we go to question number 6. Okay. Calculate the total flow dead load in kilonewton per meter square. Okay. Calculate the total dead load. Okay. Assume combined superimposed dead load of 3 kilonewton per meter square for mechanical and electrical service, partition for finishes and suspended ceiling. Calculate the total floor dead load. Okay. Here, you have to know slab. Okay, right now, every one of us are on the slab, right? Either we are on the chair, desk, cushion, or whatever, but we are on the slab. So actually, slab will support their own weight. This slab will support their own weight. Okay, guys, I sketch for you. Okay, slab here, slab with 150 millimeter thickness. Okay, slab here will support their own weight because it's made by reinforced concrete. Okay, then we set on this slab. We set on this slab with our table or whatever furniture. So means on slab, only on slab, guys. So on slab, actually there is a dead load and also imposed load. Right? Only on slab. Atas slab ada beban mati dan juga beban hidup. Okay. Then we know dead load we have self weight and also superimposed dead load. Okay. Dead load we have self weight. Self weight is reinforced concrete slab. Superimposed dead load is what? Any permanent features like mechanical and electrical service, partition, floor finishes, suspended ceiling. This one as we consider as superimposed dead load on slab. Okay, guys? Clear? Okay. So, what are we going to find out here? Total floor dead load. Total floor dead load. Okay, just now, we already have self-weight slab, right? So, self-weight slab is a dead load. Okay. So, we write down self-weight slab equal to 3.75. Then here given superimposed dead load. Okay, superimposed dead load is 3.0. So what is the total floor dead load? Of course, we just add these two values. Okay, so total dead load of slab equal to 3.75 plus 3.0 equal to 6.75 kilonewton per meter square. Okay, so cause of what? Self-weight considered as dead load. Superimposed dead load also considered as dead load. So we just add both value to get the total dead load of slab. Okay, guys? Okay, next. Okay, given that, okay, next, given, okay, still continue the story of the slab. Okay, given that the characteristic imposed load of floor is 1.5 kilonewton per meter square, calculate the ultimate load. Okay, here again, we have another term that you have to understand. Okay, characteristic imposed load. Characteristic is beban karakteristik imposed load. Beban ciri kenaan. Beban ciri hidup lah. Beban ciri. Okay. So karakteristik beban ciri is raw value. Raw value data mentah. Okay. Macam ni lah. Okay, like this. Okay, safe weight. Okay. Safe weight also characteristic dead load. Superimposed dead load also characteristic. Characteristic load. Okay, beban ciri means we get the value directly. Okay, we get the value directly. Okay, kita dapat dia secara terus. Kita kira safe weight slab. They consider to the reinforced concrete itself. So we get 3.75 for safe weight slab. So itu kata data mentah. Actual value. But once we want to construct, bila kita nak buat, bila kita nak construct the slab, the actual slab, so we have to top up the value. Kita tak boleh nak consider the actual value guys, because we have to consider the environmental factor which will affect the structure. So that one, I explained before. We have to consider the ultimate limit state. Okay, we have to consider the ultimate limit state using partial safety factor. Okay, safety factor. Okay, never mind. Let's look at here. So characteristic imposed load of floor is 1.5 kN per meter square. Here means this one. Imposed load here is 1.5 kN per meter square. See, safe weight, we have 3.75. Superimposed dead load, we have 3.0. And imposed load, 1.5 kN per meter square. Calculate the ultimate load. Okay, ultimate load. Okay, remember, ultimate load. Again, I write down here. Please remember, guys. Ultimate load, design load, factored load is a same term. Ultimate load, beban muktamad. Design load, beban reka bentuk. Factored load, beban yang difaktorkan. Is a same term. Means this value yang akan kita gunakan before we construct. Dan bila kita nak buat the real slab, so we will use this value because ultimate load, beban muktamad means we consider to ultimate design, ultimate limit state. Kita design bangunan, kita design structure kita, of course kita tak nak structure kita tu collapse. So kita kena add on. Okay, kita kena top up the value. Means maksudnya kat sini kita akan kalikan dia dengan safety factor. Okay. Okay, so from that, guys, we have 1.35 GK plus 1.5 UK. Okay, so what is GK, guys? Okay, so GK, what is GK? GK is dead load. UK is live load or imposed load. So 1.35 GK equal to 1.35 GK. GK is dead load. Okay, we already have the total dead load, right? Okay, dead load, get the total because we have total dead load before. So dead load is 6175 plus 1.5 QK is live load. Live load is given just now 1.5. Okay, so from this, here we have 9.11 to that plus 2.25. So we have 11.36 kilo Newton per meter square. Okay guys, so this one is ultimate load of slab. Ultimate load of slab. Okay, ultimate load of slab or floor. Okay, ultimate load. Okay, so how to find out the ultimate load? 1.35 GK refer to dead load plus 1.5 QK refer to live load. So this formula actually, okay guys, this formula actually are only for slab, only for slab. Okay, sorry guys, I always say slab because I'm very familiar with the term of slab than floor. Okay, it's okay guys, slab is floor. Okay, so 1.35 GK plus 1.5 QK is a formula only for ultimate load of slab because we have imposed load QK just on the slab. Okay, okay guys. Okay, okay next, the last one. Okay, for the last one, draw the load diagram of ultimate load. Okay, here ultimate load. Okay, ultimate load on beam B1, 1, 2. Label all the load values. Okay, now guys, draw the load diagram. Which what is meant by load diagram is gambar raja beban. It means beam B1, 1, 2. Apa beban yang ada atas beam B1, 1, 2? What are the load stated on the beam B112? That one we have to sketch. Okay, we just sketch the load first. Then we have label or the load value. Once we have when you have to label the load value means you have to calculate. Calculate what? Calculate ultimate load, guys. Calculate ultimate load. Okay. We will see here. Okay, let's catch the load first. Load diagram first. Okay, here is our beam. Here is our beam. We have support here. We have beam B1, 1, 2, right? So means here we have column B1, 1, right, right? Okay, and here we have column B1, 2. Okay, now refer to your own figure because I don't want to screw up. Okay, so refer to your own figure. We know these beam B112 have their own weight, have their own self weight, right? Okay, so have their own self weight. Of course, their own self weight is in uniformly distributed load. Okay, uniformly distributed load. Okay, guys. Okay, this one is self weight beam. Correct? Okay. Next, we know on this beam B12, there is also a brick wall, right? We have a brick wall, right, on this beam, right? Okay, we also have a brick wall, guys. Okay, so here we have self weight brick wall. Okay, Then, as we calculate for question number 4, how the slack panel B1, 12 and B1C, so 12 distribute their load to this B1, 12 beam, right? So, in one way, right? One way, right? One way. Okay, I scroll up before. I scroll up. Okay, here guys. Here, please get this carefully. Okay, here beam B112 support half of this leg and half of this leg. Not total load. Okay, total load of slack. Okay, total load of slack means self weight. Sorry, total load of slack is total load of ultimate slack. Ultimate load of slack is 11.36. Okay, total load of slack is 11.36. Here, okay, total load of this slack is 11.36. Means for panel B112, the total load of slack, ultimate load of slack is 11.36, and also for this beam, and also for this slack. But this beam just support half of it. Okay, so means here we will determine the value of W1 and the so here means we will determine the value of W1 and W2. Okay, W1 and W2. Okay, it's not 11.36. That one is total ultimate load of slack. But now beam B1, so 1, 2, just support W1 and W2, a part of 11.36. How to find it? We will get it. Okay, back. So here we know on this beam B112, it also support W1. Right guys? Also in UDL, right? It also support W1. And it also support W2. Okay, can you get it? Okay, just catch the load diagram first. On beam B112, we know beam B112 support its self-weight, support self-weight with wall, support W1, and also support W2. Okay, this is load diagram. Settle. But we have to label all the load value. Ultimate load, guys. Ultimate load. Okay, so we have to find out ultimate load. So let's calculate here. Okay, guys. So ultimate load. Okay, we start from the bottom. Okay, we start from beam. So self weight. Remember, self weight is characteristic load. Okay, self weight is characteristic load. So now we want ultimate load. So once we want ultimate load, remember we have to top up it with safety factor. Kalikan dengan safety factor. So ultimate load of beam. Again, beam is dead load. Right guys? Beam is dead load, right? So once beam is dead load, so the formula is for dead load is 1.35 GK. Okay, is there in 1.5 GK? No. Okay, because of what? Beam is dead load. There is no imposed load on beam. Okay, only slab have an imposed load. Okay, guys? So 1.35 GK. 1.35 GK. Okay, so scroll up. Okay, refer to your self-weight beam as we calculate before for question number 3. So GK self-weight of beam we get 1.75 guys. Okay, check yourself. So here we have 2.36 kilometer per meter. Okay. Okay guys. Okay. Next. Estimate load of beam settle. Then ultimate load of brick wall. Okay. Ultimate load of brick wall. Again, brick wall is also dead load. So it's equal to 1.35 times GK equal to 1.35. Check your self-weight of brick wall. Okay, self-weight brick wall. Just now we have 6.3 guys. Check yourself, 6.3. So the answer is 8.51 kilometer per meter. Okay. Okay. Next, W1 and W2. Okay. Special for slab, we already calculate the ultimate load of slab just now, right? Okay. So, this special ultimate load because we already calculate it. Okay, ultimate load of slab equal to 11.36 kilometer per meter square. Okay. Okay. So how to get W1? Okay, how to get W1? Okay, so here W1 equal to total ultimate load okay, Lx for W1 is 3050. 3050. Okay, never mind. I write down the formula for you. So W1 is ultimate load of slab and with Lx over 2. Because of what? We divide Lx to 2 parts, right? Okay, so from here, ultimate load of slab is 11.36. Okay, times with Lx. Lx for W1 is in meter, guys. 3.05 divide 2. Okay, so W1 is 17.32. Check kilometer per meter. Okay. Next, W1 better W2. So again, W2, ultimate load of slack is 11.36. LX, okay, LX for W2 is 3.66. 3.66. Okay, Lx for W2 is 3.66 over 2. So what is the answer? Yes, you get 20.79 kilometer per meter. So guys, as you can see here, if you can see here, W1 and W2, both unit are in kilometer per meter. See, no more meter square. Because of what? W1 or W1 and W2 already distribute load. The W1 and W2 is a slack load which is transferred to beam. Means W1 and W2 is a load which transferred to beam, on beam. Now they stated on beam. So the unit is kilometer per meter, cannot be per meter square again. Okay, so here actually we have to state it, label or the load value like the right. So you can sketch or draw it again and state the value before it. This one is 2.36 kilometer per meter. This one is 8.51 kilometer per meter. So W1 17.32 kilometer per meter and W2 is 20.79 kilometer per meter. Okay, you just draw it. Okay, redraw this diagram. Okay, guys. So we just answer 1, 2, 3, 4, 5, 6, 7, 8. 8 question for analysis load on beam. So please do again this. Thank you. Good luck. Assalamualaikum. Bye.